All right, good morning to day 3 of OCP. We're so glad that all of you could wake up early, drive in to beat the Bay Area traffic and join us for our presentation today. My name is Matt Burns, Director of Technical Marketing at Samtec, and I'm joined by some of the luminaries in the PCI-SIG ecosystem as well as in the OCP ecosystem. As you can see from our title slide, our theme of our presentation, PCI retimers and cables, the backbone of infrastructure. The thought process, the genesis of why we started thinking about this within PCI-SIG is the fact that we see extended cable needs across the data center infrastructure space. We see it within AI, yet we still need to use retimers in a lot of instances. So the technology leaders we have here on this panel discussion are going to answer questions that PCI-SIG has come up with to address those topics. And when do we use a cable? When do we use a retimer? When do we combine them? And then hopefully towards the end, we'll have time for questions from the audience as well. So to get started, before we get into the panel discussion, we just want to give a quick overview of PCI-SIG. PCI-SIG is definitely one of the industry leaders when it comes to standards. Dating back to the 90s, PCI-SIG actually started with the PCI spec in 1992. The responsibility of PCI-SIG as an organization is to define originally PCI and now PCIe bus specifications and related form factors. Started with one specification, now it spans handfuls to dozens. The first original PCI spec, for those that have been around long enough, was introduced in 2003. Currently, we have over 960 plus members, and we're anxiously and optimally looking forward to having 1,000 members here in the near future. And again, key responsibilities for PCI-SIG, creating specifications and mechanisms to support compliance and interoperability across the PCI Express ecosystem. You can see the current board of directors. No doubt many of them are here at OCP, and they continue to be leaders in their respective spaces in the technology ecosystem. So some may ask, and some may wonder, PCIe cabling, CopprLink, is that all there's ever been? But if you look at this graph, it really shows how PCI-SIG has anticipated the needs of the market, not only from a copper standpoint, but from an optical standpoint at getting high-speed data rates over longer distances as the use case demands have required. So Äîallowing came out in 2015. More recently, we have the CopprLink internal and external cabling. Several demonstrations are here on the floor for both infrastructure, both for the SFF-TA 1016 and the SFF-1032. PCI-SIG continues to work on next generation standards for external cabling to support PCI-5, especially in the optical ecosystem. The working group has been meeting over the last 2 years, last year and a half, sorry, I can't read dates. And we'll continue to gather input from thought leaders, PCI-SIG member companies to define next generation standards. So there's a long history of cabling initiatives, cabling technologies within PCI-SIG, copper and optical, but we're not here to talk about the past, we're here to talk about now and into the future. So I'd like to introduce our esteemed panel. I have my colleague to the right, Dave Kulansky from Alphawave, Chris Blackburn from Astera, almost said Altera, wrong company, sorry. Xin Liu from Montage, I can't see the type, I'm sorry. Sorry, Xin, and then Subhash from Kandou. So sorry for the mishaps there, gentlemen, thank you for your patience. So to get started with our discussion, make sure I got my questions here. So to get started with our discussion, obviously here at OCP, AI is a tremendous interest to everyone on the floor. We've seen a tremendous amount of disruption in the data center, how AI topologies are redefining how we think to implement our systems. But when we start to think about PCI-SIG, what are some of the use cases or topologies for PCI retimers in that space?
So some of the topologies that are coming out are expanding out on what we call composable systems. Because what we need is flexibility in each element in the AI infrastructure for connecting multiple GPUs, CPUs, NIC cards, storage. And what the PCI-SIG has done in adapting in these new protocols is to enable us not to change a protocol. So we actually get still low latency interconnect as we create very flexible, very scalable, and very reconfigurable systems to match the ever-changing workloads. And as you see the change in the type of models that are being used in LLMs, in the RAG pipeline, and so on, we do need flexibility as we start adapting to trillion parameter models, 10 trillion parameter models going forward. And this is what the retimers and new retime cables enable us to do.
Very good. Thanks, Subhash. Xin?
Yeah, actually, I want to add to Subhash, his opinion. Right now, I think we're mainly seeing retimers and cables are mainly for UBB, for AI servers, and also like a connection between the head unit and the computer box. I think most likely that's in the form of CDFP cables or the like. So we expect, this topology is going to continue to evolve, as data rate increase for PCI 6.0, 7.0, and even 8.0. And also, at the same time, we are seeing some emerging connection topologies, for scale-up connections of the GPUs. That will be like, probably like external cabling. It can be active electrical or optical, depending on the reaches you have. So I think, the formation of the working groups within PCI-SIG will greatly expedite progress. Yeah.
Xin, I want to congratulate you. I think that's the first reference to PCI-E I've heard at this conference. So congrats. No pressure on the rest of the group, right? Dave, do you have a thought on the topic as well?
So I think Xin covered a lot of the thoughts that I was having there as well. But as the topologies grow, and Subhash said, 10 trillion parameters, it's just going to need us to go to optical because the CopprLink reach is not going to be enough, and CopprLink is going to open up those doors to allow things like pluggable optics that will be needed for that next set.
Okay.
You have
so,
questions.
Yeah, so that's a good point. That's a good point. And it kind of leads into our next question. I think this one's directed back to you, Dave. How does the PCIe CopperLink cable specifications and optical specifications in the works address AI system topologies?
Oh, perfect. So CopperLink is there right now to help extend and standardize this. The protocol, and it's going to be very key for PCIe 6 and PCIe 7. But as I was alluding to earlier, CopperLink, because of the standardization, will allow us to do these optical pluggable modules as well, which is going to just make it easier and more standardized for the technology to move forward and do that interact as opposed to just interact with PCIe.
Yeah, very nice. Something related to that, and maybe Subhash, maybe you can comment on this. How's optics play off this?
So optics gives us distance, but with the CopperLink spec, we can actually start mixing and matching and reallocating the overall insertion loss budget. So it gives us extended capabilities to create larger and larger clustered systems. And as we start looking at what NVIDIA has done with the NVL72 and going beyond, and some of the discussions that were there yesterday during the optics session, we're starting to think about clustered systems getting up to 500 GPUs. And there's no other way to do it than getting into these pluggable systems and being able to deal with a larger insertion loss budget to keep the protocol flat at this layer.
Very nice. Chris, we haven't heard from you yet, so we want to make sure we get you involved. Can you comment on, we've talked about AI topologies. What about disaggregated computing?
Yeah, so Subhash talked a little bit about disaggregated computing. So typical servers have, compute, memory, NICs, maybe accelerators all in one chassis, right? And we're seeing that spread out throughout the rack. So at the show here, if you go by some of the booths, you'll see a J-bomb, so just a bunch of memory in one rack. And when we disaggregate that, we now need cabling that goes from the compute nodes that might be in another height in the rack elevation. It might be in an adjacent rack, right? And depending on where that's physically located, that's where we get into some of the active electrical cables, even the optical cables. So it's not just memory being disaggregated, but all of the resources across the data center. And one of the things Subhash brought up about efficiency, right? When you look at these monolithic servers and you have all of your resources in one box, if you can't utilize all those resources, right, they're just sitting idle. When we look at the disaggregated architecture, right, you can use what you need when you need it for a more efficient data center.
Yeah, very nice.
Touching on that point, just one other item. When you're leaving something unutilized, that's OpEx cost. And so one of the big things going into composable computing and disaggregated computing is trying to reduce the overall OpEx cost as you scale these applications.
Very nice. Shane, I want to make sure we can keep you involved too. Can you expand upon a little bit what PCI-SIG is doing to handle rack-to-rack and larger clustering?
Yeah, I think, one area is PCI-SIG, as Chris mentioned, one typical use case is for the memory pooling, with CXL. I think right now, PCI-SIG, the standards kind of evolve simultaneously with CXL. So we're seeing, for CXL 2.0, 3.0, there will be more use cases for memory pooling. I'm sure the external cabling and also retimers will going to play a big role in that area. Yeah.
Very nice. I appreciate that. And gentlemen, if you have if anyone else wants to jump in on some of these topics, no pressure.
I was too late on the
That's my fault.
Maybe one more comment.
Yeah.
If you guys go by the Inventec booth, there's an interesting J-bomb system there. It has 12.8 T of memory, and there's retimers in the front with CDFP cables like Xin talked about. So it's a good example of this disaggregated architecture, composable memory.
Yeah, very good.
And also, same thing in the innovation village. Everything's on display: SCON, PCI switch, CXL switch, and a lot of J-bomb boxes over there. You can go to have a look. We expect this grow because I think it's very good synergy for the CXL PCIe initiative. Yeah.
Yeah. So obviously, we see a lot of disruption. We see a lot of innovation. We see a lot of different use cases. And it seems like it's evolving faster and faster. I think one of the things I think we've all seen here on the floor at OCP is innovation is just happening at a rapid pace that likely none of us have ever seen in our careers. So that poses new challenges to industry standards organizations like PCI-SIG. We're being forced to adapt and keep up and address the opportunities or the challenges that the industry presents. So. And we can maybe address this to all of you, but when you look at the challenges that we've talked about so far, how is PCI-SIG addressing this, whether we're talking about larger models in disaggregation or optical, clustering, using optical technologies that we see in AI systems?
So I'll jump in first.
Yeah.
So PCIe is the standard of scale up as of now, and hopefully it stays that way as long as we get to PCIe 8, right? And so the larger and larger models, the 10 trillion parameters, hopefully not too soon, but getting there, it's just too big for a single rack. And PCI 6 was good enough for that when it was intra-rack, and PCI 5 was probably good for multiple racks. But PCI 7, there's no way you can go more than top of rack to top of rack, and to get this 10 trillion parameters, you're talking many racks. And so the only option is optical, and optical can handle really any length of distance as far as the channel goes. There's no limitation. But the limitation is still latency. So you need to consider, what your application is. So PCIe is very flexible. So CXL is streamlined, and that's more of a low latency option of PCIe. But depending on what you're doing, the only limitation is going to be latency. And so we have some trade-offs that we can do where it might be clever chip design that can get you these lower latencies needed to shave off a few nanoseconds, because nanoseconds matter. Especially when you do round trips. And so optical's going to be the way of the future for PCI 7, and certainly PCIe 8 there's no option.
Yeah, very nice.
Yeah, maybe I'll add a comment about the bandwidth of the connections, right? So we look at previous generations, there were a lot of by-4s, and if you wanted to buy 16, you use 4x4 connections, right? So if you look at the form factors that are in the CopprLink spec, right? By 16, we just have this appetite for bandwidth to get to from the GPUs and CPUs and connect all these things together, right? So we're seeing an increase in that. I don't want to predict the future, but I think that's going to be a relentless pursuit, right? So if we look at some of these disaggregated systems, right, it's by 32s or even 96 lanes going from point to point. So we're still in that scenario. We've now quadrupled the bandwidth of the connection, and we're still running multiples of those from point to point. So it's a relentless pursuit for bandwidth.
Chris, I think it's okay to predict the future because Xin's already started the ball, so it's
Yeah.
all right. No pressure.
Yeah.
So maybe just to get a little bit more detail, we got an extra minute or two. Maybe we could just get some more input from the panel on optical, large clustering with GPUs talking back and forth. Obviously, a huge demand for optics there, and we've talked a little bit about some of the work or we've alluded to some of the work that PCI-SIG is doing in that space. Could you expand on, and any one of you, this is kind of for all of you, can you expand upon your viewpoint on where we're going with optical, PCI Express over optical, by expansion, CXL over optical for clustering applications?
Yeah, I'll jump in.
I didn't mean to stump on.
No, that's good.
Guys.
Yeah, I'll jump in.
Yeah.
So maybe a couple trends to kind of set the question up.
Yeah.
One of the things we see increasing is power density, right? So you have more compute within a rack, and then the racks are getting larger. They're getting wider. They're getting deeper. That we moved from an RU to an OU, and some customers are building 2, 3, 4 U boxes, right? So when things are getting larger, you now need, and you're stacking them up in these large clusters, right? The distances increase. So for optical standpoint, my take on it is you're going to have passive copper where you can use it. Mm-hmm. Then you're going to move into active electrical cable, use that where you can use it, and then use optics where you have to use it because there's a physical limitation, right? So it's a cost optimization game with length and reach.
Yep.
The other way I look at it is it's also a optimization on reliability. Mm-hmm. So when you think about passive, it's very reliable, nothing there. With active electrical, next level, you need a little bit of extra protection. And then when you get to optical, based on the native BER, you need even more protection, which adds an extra latency. So as you're starting to go over and tier the connections, you're actually balancing the latency with the reliability. As you're getting higher and higher speed optical, you need more and more error correction, which adds more latency. And so it's trying to balance each of these things as you start thinking about how the applications are built.
Very good.
I just want to add, for the optical, I think we kind of need expedition on the SIG level because I think we need an ecosystem that can enable the optical. Right now, I think, there are different, teams or companies working on different fronts, yeah. But I think we're kind of lacking a unified, efforts with the SIG. I think that's where we can work together to make that happen. Yeah, that's kind of critical.
Yeah, I think that's a good point, Xin, because if you look at not only at OCP or trade shows over the last 3 to 6 months, there are literally handfuls or maybe dozens of PCI Express CXL over optics. It's various speed, it's various generations, PCI 3 to PCI 7, not PCI 8 yet. There's different form factors, and this is, these types of things, Samtec's involved with this, these types of challenges, these opportunities are definitely something that the industry needs to address. Sorry, I didn't mean to interrupt you, Dave. Go ahead.
All good, Matt.
Yeah.
I was just going to say, I think everybody's touched on it here, and so I want to chime in and agree as well. Total cost of ownership is
Yep.
really what's driving things. So if you can get away with plain copper, it's free,
Yep.
right? Like it's almost free. And then the active copper, it's a little bit more expensive. And then the optical, you start using watts.
Yep.
Like you're talking watts, not milliwatts suddenly. And that adds up really quickly. And so if you think of this total cost of ownership, you need to think about how little power you can spend, because one of the presentations was saying we're going to be spending $70 billion a year on energy. Yep. on just these data centers, which is crazy. Melting the ice caps. But then also you just need to think of also serviceability,
Yep.
because that's a huge cost. If you have to take out your entire board, that's not cool. right? So you need to do things like co-packaged copper where you just plug it in.
Yeah.
And so that's copper, so it's a little cheaper, and it's co-packaged, so it's easy to replace. And then you need to think about these pluggable optics as well.
Yeah. So I want to thank you, gentlemen. You've done a really nice job of kind of capturing the reality of where we're at right now from an interconnect standpoint. You know, whether you're looking at copper, you're looking at optics, but all of you obviously work for retimer vendors. So we want to make sure that we cover that point. So maybe to look at it over the last 10 minutes or so of our panel discussion, how do we see retimers and cables interoperating in OCP form factors, OCP technologies to support AI? And I'd love to get input from each one of you. So whoever wants to start.
Yeah, I'll start.
Yeah.
So if we look back at kind of the history of the system architecture, right, we see these large PCBs, long traces, right, and as we go up in PCIe generation, you're losing budget. So then we see internal cabling kind of hit the market, and a lot of the architectures are using internal cabling. As we go to PCIe Gen 5, Gen 6, Gen 7, Gen 8, the internal cabling is still not enough to get there, right? So we're going up in frequency. We've moved to PAM4 modulation as we get to PCIe 6. So we see a big combination of retimers and internal cables. And then, of course, as we leave the box, as we've been talking about, retimers with the external cables. One comment I want to make, we talk a lot about reach here. One of the other aspects for system designers is cable gauge and flexibility, cable routing, right? So those things are equally as important as reach. So we may not need a 2 or 3 meter cable in an internal system, but we sure want a 32 or 34 gauge cable so we can route that around.
I just want to add, on OSP level, I really think, we should have a kind of a standard, for retimers or cabling, because for HGX, it's kind of critical for enabling retimers for AI servers. So with the evolution of 5.0, 6.0, or down to 8.0, I really think there should be some, standardization efforts on the OCP level to enable wider adoption of retimers. Yeah.
Okay.
So I was throw in the open chiplet economy, which we've been hearing about over the last few days here with OCP, making this democratized set of chiplets that are available to everybody. We're looking at it as a company, but lots of people are as well. The ability to bring compute right up to your I/O, and so if you do that with an MCM, you can do it where you're talking sub-picojoule per bit, maybe sub-half picojoule per bit, which is amazing. And then on the other side, you have PCIe, and you can use that already available economy of ready-to-use PCI retimers and cables. And so, all of these products that are already there, ready to go, are there, and you can just build larger and larger compute chips in these massive MCMs.
Nice.
The other area, as we start expanding out, is really thinking about metrology and using what you have in retimers to actually understand what's going on in the system. Today, we have basic telemetry to give us a view of the health of a system. But the opportunities are there to expand that to get to more of a predictive view. So you can actually think of things like the drift of an eye. So you can start thinking about, as the eye margin changes over time, it may be the time to properly replace that board or that subsystem. So thinking a bit more almost on the thought of AI for AI, where you're looking at using all the information that you're covering just to make sure these systems are healthy, and making sure you understand the other part of RAS, serviceability, to be able to take them out and make sure that all your week-long, month-long training sessions actually have good data.
Very good. Well, we appreciate your comments and observations on those topics. We have a few minutes, so we'd like to open up to the audience if there's any questions for our panelists. Sir?
Steve Glazer, PCI-SIG Board of Directors. One of the things that is interesting in the base 7.0 spec, we will be supporting 4 retimers per link. So the issues that we have today of you can only have 2 are going to go away. It will require new retimers. So if you want all 4 of them, or if you want 4 retimers, you have to have all 4 retimers being newfangled stuff. I think we're going to be able to get away with one old style and two new ones if you want 3 retimers, as long as the old style is on either end, not in the middle. And then we're also doing some optical retimer work. And both of those are intended to be visible at the 0.7 or 7.0 published date, so we're not, they'll be essentially part of the same thing, although they're going through independent approval tracks.
All right, very good. Thanks for the commentary.
Yeah, maybe a quick comment on that.
Yeah, please.
We all love more retimers and links up here. But no,
Really?
a common topology with the 4 retimers, right? If you think about putting the retimer on your board, on your system, and you have 2 systems, well, you've already used the 2. So you can't use an active electrical cable. So a common topology with the 4, you have a retimer on each system, and then also a retimer on each end of the cable for that reach extension.
Very good.
I was just going to throw out, and maybe this is a naive way of looking at it, but if you have it go to optical at the edge of your board, you should not need more retimers than that, right? So your optical can cover really a nearly unlimited length. It's just the latency, but every topology has latency, copper or optics.
Yeah, that's the other thing that, in the old days, retimers had about the same latency as a switch, roughly 100 nanoseconds latency. And so one of the things that I think the world needs to be informed of is you guys got smart, and it's nowhere near 100 nanoseconds anymore. It's down in the tens, if not less. Another thing you can do in flip mode is because you're sending ACKs and NACKs a lot more frequently, without doing anything special, you can measure the latency of the link. And that's kind of useful for some of that instrumentation kind of stuff that you were talking about earlier.
Yep, it makes the ACK and NACK gives you a really nice visibility when you're looking at changes in system latency as you start going through multiple stages of PCI switching. So getting views of CD95, 99 latency becomes sort of interesting as you go in these large topology networks.
Yeah.
This might actually be for Steve. When do we see the spec coming online for, the optics specification under the PCIe SIG? Do we have any ideas on that?
Okay, the optics stuff is being done as an ECR. Its goal is to be official in time that it can be incorporated into the base 7.0. The base 7.0, I'm in the middle of working on trying to get the document wrangled into shape for the 0.7 release, which is we finally have it incorporated into the spec. It's still not this is it, but this is the 5.0 was, we're going to do these changes, or the 0.5 rather was, we're going to do these changes. The 0.7, it says, we did them. Here they are. And the 0.9 is, yeah, we're mostly done. And then 1.0. The goal, again, is 1.0 mid-next year.
Good. Steve, next time we do this panel, you should be up on the stage with us. Great answer. Thank you. Please, any other questions?
I was
sorry.
just going to throw in one last thing. I think wisely the PCI-SIG has partnered with OIF, which has a lot of familiarity with optical, and so there are a lot of optical experts already working with the PCI-SIG in conjunction, so that it is a happy marriage between those two groups.
Very good. Thanks. Last question.
I have 2 questions. One question is the system design point of view, retimer, redriver, optics, everything they need real estate. So any opinion and activity to reduce the retimer, redriver size or optic size to minimize system design risk? And another question I have is, if it's optics cable, root complex and endpoint become longer and longer and longer, any bottleneck of low control signal and clock signal, because distance is too long. I don't know how handle control signals.
You stumped us.
So I didn't get all of the questions, but just one of them I caught was, the distance gets to be very long, and so the optical work group is working on details of how to handle these sideband and management signals, and so it might be in band, it might be sideband, it might be a side of copper, it might be another fiber, and that's all getting worked out, but it shouldn't be it shouldn't be more challenging to transmit those management and sideband signals than it is the actual high-speed data over the glass.
From time constraints, we're going to have to cut off the questions. My apologies. Thank you again to Subhash, David, Chris, and Xin. If there's more question and answer, our panelists are available right after we're done. One last thing, call to action. Obviously, there's a lot of work going on within PCI-SIG. We invite all to join and help shape the future of PCIe, not only our PCI-SIG technology, but cabling. And you can find more out about PCI-SIG on the website, PCISIG.com, LinkedIn, X, YouTube, and Bright Talk. So thanks, everyone. Thanks again to the panelists, and we look forward to interacting with everybody on the floor. Thanks again.